Hey guys, we got a task here. We're going to talk about interpreting and computing quotients. Okay, so we're going to kind of pan up so we can read it as y'all can read it as I'm reading. Alicia really wants to ride her favorite ride at the amusement park one more time before her parents pick her up at 2:30 p.m. There is a very long line at this ride, which Alicia joins at 1:50 p.m., which is point A in the diagram, which is there. Okay. Alicia is nervously checking the time as she's moving forward in the line. By 2:03, she has made it to point B, which is 2.203 right there. Okay. What is your best estimate for how long it will take Alicia to reach the front of the line? So she goes here's the line, zigzag line, and here's the front of the line. So that's the first question we're going to answer. Then it says if the ride lasts 3 minutes, can she ride the ride one more time before her parents arrive? Okay, so I've kind of rewritten the diagram right here. Okay, so she starts right here at 1:50 p.m. Okay, so we know at point B it is 2:03. So we know from that's like a 6. It's a 0. So we know from 2:03 minus, let's pan over here, 1:50, that is going to be 13 minutes, okay? So it takes 13 minutes to get to each route, okay? So 13 minutes, okay? So we can see that the shape of it is kind of like an L, okay? So she goes over and down, that's 13 minutes. So there's another over and down, so we're going to call this point C. We know that's 13 minutes. Okay, so over and down, just like the first one. We're going to call this point D. And we know from point C to D, again, it's going to be another 13 minutes. Okay, then go over and down. Again, that's going to be our point F. And we know that route is going to take 13 minutes. Okay, and then over and down again, there's another 13 minutes right there. Okay, all right, so multiple ways of doing this, okay? So we know, let's see, 1, 2, 3, 4, there's 5 distances between the points, okay? So we're going to do this fraction-wise, okay? So like I said, we could do the 13, 13, 13, 13, 13. So each section takes 13 minutes to navigate, okay? Now, we're going to be talking about fractions, okay? Each one is, let's see, 1, 2, 3, 4, 5. So each section is 1/5, okay? Hope you guys can see this pretty good. Okay, so if you add all these up, that is 5/5, so that's the entire route, okay? And we know it's going to be 1/5 of the route takes 13 minutes, okay? So if there's 5 routes, it's going to be 13 times 5, 15, carry a 1, 65 minutes, okay? So we know this is 65 minutes. 65 minutes to go the whole from point A to the front of the line. Okay, so her parents are coming at 2:30. She gets in line at 1:50. 1:50. Okay, the parents are coming at 2:30 from the beginning of the problem here somewhere. 2:30 p.m. The parents are coming to pick her up at 2:30 p.m. So the question asks us, what is your best estimate for how long it will take Alicia to reach the front of the line? Well, we know it's going to take 65 minutes, okay? So let's see how much time she has originally. So if none of this was going on, we know that she's got 10 minutes from 1:50 to 2 and 30 minutes from 2 to 2:30. So she got 40 minutes to get on the ride and ride the ride. Okay, so 40 minutes, but just standing in line is going to take 65, plus the ride takes 3 minutes, so it's going to take a total of 68 minutes to get from point A to the front of the line and ride the ride. So there's her best estimate, 65 minutes. Now, is she going to have time to ride the ride one more time for her parents to get there? And we know that is a resounding no. Okay? All right.